Hey everybody, in this video we'll discuss two important topics or ideas, a permutation and a combination. And these are used in counting techniques, all right? These are used in counting techniques. So the main difference between these two is the specific order before I read it. So one has it, the other doesn't. Permutations, a permutation of n objects taken R at a time is an arrangement of R of the n objects in a specific order. So we will see this in an example. However, for a combination, it's almost the same thing, just here there is no specific order. A combination of n objects taken R at a time is a selection of R objects from among the n with the order disregarded. Okay, so when you see this notation PNR, it's the number of permutations of n objects taken R at a time, and for C, it's the number of combinations of n objects taken R at a time. Luckily, these come with these formulas and they make it easy to calculate. And you will see something here that you have, it's factorial, this symbol here, which you also have on your calculator. And you should review these factorial properties. So PNR, the shortest way to say it, or the number of permutation of n objects taken R at a time, it's n factorial over n minus R factorial. For the combination, it's slightly different. The combination has this R factorial here. It's almost same formula with R factorial. So let's look at these two examples to reinforce this. Selecting a committee, we have a board of directors of a corporation has 10 members, so n is 10. In how many ways can they choose a committee of 3? In how many ways? So we're counting how many ways we can select this. And you will see this will help you with decision making. You know, how easy is your decision and how difficult is the decision to make, you know. 3 board members to negotiate a merger. So here there is no mention about the order. You have 10 and we need to take 3 out of those 10, right? So there is no specific order. So what do you think we should use? All right. So it should be the second one, which is the combination. So C, this way. Then it's going to be that 10 factorial. All right. N minus, let's write the whole thing here. So R factorial is 3 factorial. And this one is going to be 10 minus 3 factorial, which is 10 factorial, over 3 factorial, 7 factorial. So if you want to see 10 factorial, what it means, it's 10 and you decrease by 1 times 9 times 8 times 7 times 6 times 5, 4, 3, 2, 1. So 7 factorial, as you see, the bottom one is going to start here. So we will have these same numbers, right? One you know, let's just write it so you understand how it works. So for 3 factorial, it's going to be 3 times 2 times 1. So if you put it this way, it allows for the elimination or to cancel. 3 divided by 3 is 1, 2 divided by 2 is 1, and that should leave you with 10 times 9 times 8. 10 times 9 times 8 over 3 times 2 times 1, which is 120 ways. So 120 ways of choosing a community of 3 out of 10. That's why, you know, too many ways, right? So this is why this is important. So just to understand the bigger picture. Selecting, you can call this example 1 and this is example 2. So selecting club officers, you know, if you have, there is some type of ranking or some type of order. Anytime you have a, let's say, president, vice president, for example, as you see for example, in elections, you have a president, then you select the vice president, right? You're not going to select the vice president and that president didn't win, for example. So there is some order there. A club has 10 members. In how many ways? So n is 10. In how many ways they choose let's just see a slate of 4 officers, so all 4. Consisting of a president, vice president, secretary, treasurer. So there is an order there, right? So this implies the order. In this case, we're going to use the permutation formula, which once you use the combination formula, the permutation one is even easier. 10 4, 10 factorial over 10 minus 4 factorial. And here, as you see, it's 10 factorial over 6 factorial. And as you see, when these 7, once I got to 7, it's 7 factorial. So I could break it down this way, or I could just show you the shortcut here and simplify. So 10, 9, you see, I keep in mind this 6, 9, 8, 7, 6. Instead of writing 5, 4, I just say I reach 6 factorial, because after 6 it'll be 6, 5, 4, 3, which is 6 factorial. And at the bottom I have 6 factorial, which means that's a compact way of doing this writing here. So you can do that this way. So it's 10 times 9. Let's rewrite it. So 10 times 9 times 8 times 7. It's 5,040. All right. 5, 6 has just a complement rule for counting, and it's a straightforward formula. I think once you need it, you will use it. But mostly for these 2 sections, 5.5 is the one in which you're going to do a lot of different examples. And for 5.6, the view is a set of all possible outcomes. And S is a subset of U, all right? Then S complement is the set of all outcomes for which S does not occur, of course. So in this case, the number of elements in the S complement is going to be given by this difference formula, all right? And it's called the complement rule for counting. That's a straightforward formula, and I'll stop here. Thank you.